assignments, doubts, exams. We have got you back. EduPlanner make every chapter easy to understand. Stay tuned, learn more, grow with us.
So for this problem, we are dealing with a 3 kilogram particle that is oscillating and moves according to the equation x equals 5 meters times the cosine of pi divided by 3 rad t minus pi divided by 4 rad. And we're trying to find when our potential energy equals, at what position of x will our potential energy equal 1/2 of the total energy, as well as how long it will take for the particle to move from x equals 0 to that position. So the first thing we're going to want to do is just take a look at our equation here and see what other information we can gather from this equation. And we can also get that our xm, our amplitude, is equal to 5 meters. And we get that directly from the equation here. That tells us our amplitude. Next, we need to think about what we want here. We want our potential energy to equal 1/2 of our total energy. And we have the equation for potential energy is 1/2 k times x squared. And we want that to be 1/2 of our total energy, which is 1/2 k x m squared. And now we can rearrange this to solve for x. So first off, our 1/2 k, that's going to end up dividing out, which will give us x squared equals 1/2 xm squared. And then we take the square root of that, which will give us x equals xm divided by the square root of 2. Now, as we got from up here, we can substitute our 5 meters into our equation here. So we end up with x equals 5 divided by the square root of 2, which gives us a value of 3.5 meters. All right, and now to find the time it takes for the particle to move from equilibrium to 3.5 meters, we're going to go ahead and take this and plug this value into this equation here. So we'll end up with 3.5 equals 5.0 times the cosine of pi over 3 times t minus pi over 4. And we can go ahead and solve for t here. So we're going to, instead this time, solve for t. So rearranging our equation, we'll end up with t equals pi over 4 plus 3 over pi inverse cosine of 3.5 divided by 5. And we end up getting a time of 1.54 seconds. But we are looking for the interval that it takes for the particle to go from this point to, or from equilibrium to this point. So we also need to figure this out figure out the time at which the particle will be at equilibrium. So we're going to do t, and we'll just put t equilibrium equals, and we're going to use the same equation, pi over 4 plus 3 pi inverse cosine of 0, because we're dealing with our equilibrium, so it'll be cosine of 0. And with this, we get that our t value equals 2.29 seconds. So to find the interval, we're just going to subtract 2.29 minus the 1.54, and we get that it takes 0.75 seconds for it to go from position X, or from equilibrium to position X.